I'm going to briefly show how to use an interactive simulation for a system that has vapor liquid equilibrium. So it's a binary system, and the simulation is located at the link indicated here in blue. And if we look at a snapshot of what the simulation is, we're plotting temperature on the y-axis versus the mole fraction of component B. And then to the right, we have a bar graph that shows the number of, if we have a total of 1 mole, how many moles are in the alpha phase in this case, and how many in the beta phase for this particular point. And so the alpha phase is mostly component A, and B is partially soluble in A at that composition regime. And the beta phase is mostly component B, with A being partially soluble. So at this temperature, 77 degrees C, we can have all three phases: the alpha phase, beta phase, and vapor. And then, of course, at the higher temperatures, we have all vapor. This region corresponds to the alpha liquid in equilibrium with vapor, and this region, the beta liquid in equilibrium with vapor. So the simulation allows us to move the point on the temperature mole fraction diagram by adding heat or by changing the mole fraction of B, the overall mole fraction. So let's look at this simulation. So we're below 77 Kelvin. I can move this mole fraction, and as it moves to the right, we have more of the beta liquid, less of the alpha liquid, and the amounts we can determine just from the lever rule. And now let's add heat. So let's start from here. As we add heat, the relative amounts and their compositions change. As you can see, the composition, the solubility increases of component B and A for the alpha phase. So as you add heat, the mole fractions change, we have more alpha liquid, and then we get to this temperature, 77. Now as we add heat, we start to form vapor. And we add more heat, the temperature doesn't change, and instead we get more vapor. And of course, we form the vapor by both alpha liquid and the beta liquid evaporating to form the correct composition in the vapor phase. And you'll notice that we're going to get to the point where all the beta liquid will evaporate. Now we just have alpha liquid and vapor phase. And now as we add heat, the temperature starts increasing again, and we're in the two-phase region until we get to this point here, where now we have all vapor. The details show the mass balances that we use to determine the bar graph. We can also, of course, decrease the heat and go in the other direction by removing heat from the system. So this is a case where two liquids, two pure components, only partially soluble, and we're looking at a temperature mole fraction diagram to understand their behavior.